Good evening, students. So I will discuss the comprehension, the STEM questions, question number 15 and 16. So let's talk about the question number 15 first. So as you can see, the question is like given as consider the curve C1 is given by y equals to e power minus x. And we have another curve which is y is equals to e power minus x cos x plus sin x. Okay. So both are defined for x belongs to 0 to 10 pi. And also they have given let n be the total number of points of intersection of the curves C1 and C2. So let's try to find out the C1 and C, the point of intersection of both. So if you try to find a point of intersection, so e power minus x will be written as e power minus x is equals to cos x. So as you can see, we can get 1 equals to cos x plus sin x, right? Now what we can do, we can transpose cos x on other side. And we can write 1 minus cos x, we can write as 2 sin square x by 2, right? And similarly, we can write sin x as 2 sin x by 2 into cos x by 2, right? So from here we can say that we can get two roots, like we get sin x by 2 equals to 0, or we'll get sin x by 2, that is sin x by 2 equals to cos x by 2, which can be written as tan x by 2 equals to 1. Okay. So if we see this one, sin x by 2, so sin x will be 0 at 0, it will be 0 at 2 pi, it will be 0 at 0, 2 pi, 4 pi and so on, since it is going up to 10 pi, right? Now let's talk about the tan x by 2. So tan x by 2 will give us 1 at x equals to pi by 2. Okay. Next will be, again it has to give the positive value, so it will be 5 pi by 2. Okay, so if you observe this, our interval is given from 0 to 10 pi, right? So 0 to 10 pi, so 0 to 10 pi, 10 pi is the boundary point, right? So if you observe that 0 is from 0 to 2 pi, we have pi by 2, right? So we can say from 0 to 2 pi, we have pi by 2. Obviously 0 is included. And then what? How many total points we are going to get, because it is going up to 10 pi. So from 0 to 2 pi, the length will be like, so we can say we will get the length of 6, right? So 0 to 2 pi, 2 pi to 4 pi, 4 pi to 6 pi. Similarly, we'll get how many total lengths? We'll get 6, right? So every interval will get 1 point. So total how many we have? Total 6, right? And every interval will get 1 point. So total will get around 11 points, right? So 11 points will be 0, pi by 2, then 5 pi by 2, then 9 pi by 2, then 13 pi by 2. Next one will be 17 pi by 2, 21 pi by 2. Okay. And we have to go up to so you can see that 0 to 10 pi. So 0 to 2 pi we got pi by 2. Okay. So likewise we'll have the double points. Total will get, including 0, we'll have n value as 11. Okay. So let's talk about the next part of the question. In that they have given, suppose that a1, that is alpha 1, alpha 2, alpha 3 up to alpha n belongs to 0 to 10 pi, right? And are the x coordinates of the points of intersection of the curves C1 and C2 such that alpha 1 alpha is less than alpha 2. So we can say 0 is less than pi by 2, which is less than 2 pi, which is less than 5 pi by 2, and so on, right? And what they are asking in the second part of the question number 16. Okay, let beta be the area of the region enclosed between the curves, right? C1 and C2. And the lines x equals to alpha 1 and x equals to alpha 4, right? So if you look at here, let's try to understand the graph of this. So first thing, it is given as e power minus x. So e power minus x will get something like this, right? Another curve they have given y equals to e power minus x sin x plus cos x, right? So we know that if I put 0, we are going to get 1, right? And similarly we'll get something like this, and it will keep on continuing like this, you know. So I can say this point is going to be pi by 2, this point is going to be 2 pi, and this point is going to be 5 pi by 2. We don't have to go after 5 pi by 2 because they, according to the question, they are asking for x equals to alpha 1, and they're asking the shaded region between x equals to alpha 1 and x equals to alpha 4, right? So they are only talking about the 4 points from 1 to 4, right? So we have 0 to pi by 2, 1 interval. Okay then. So if you observe this, I can say if I subtract the curve 2, that is C2, from the curve C1, or we can write this way. So I'll have the interval like 0 to pi by 2, C2 minus C1. Okay. Next will be what? Plus pi by 2 to 2 pi. If you observe that now this e power minus x is above the e power minus x into sin x plus cos x. So I can write C1 minus C2. Okay. And the next will be 2 pi to 5 pi by 2, right? That will be again now this curve. So C1 minus C2. Sorry, C2 minus C1 this time. Okay. Next thing is now C2. What is C2 here? C2 is e power minus x sin x plus cos x, okay, minus e power minus x, okay, dx. So if you observe that almost like we don't have to worry too much about the integration because all the integrations are same, just we have to change the sign, right? So let's do one thing, get the integration of this, and similarly we just change the sign and we'll get the remaining integration, correct? So let's try to solve this one first. So e power minus x cos x plus sin x plus cos x, because this we can do easily, right? E power minus x will get directly minus e power minus x, right? E power minus x into sin x plus cos x. If I try to do the integrate this, if you remember, we have one identity property, we can say f of x plus f dash x, which we know that it is going to be e power x f of x, right? So if you try to compare with this, we have positive x here, right? But we have negative x. So no issues. We can directly replace minus x with the t to make into that form. So we'll get what? X equals dx is equals to minus dx is equals to dt, right? Similarly, we'll get dx is equals to, now what we'll get? Dx is equals to minus dt, correct? So using this we can get, it will become e power t, and now I will get sine of minus x. Now x will become what? Minus t, so I will get minus sine t, and cos of minus x will remain as cos x, it will be cos t. Okay, hope you have understood up to here. So from here we can say ki, now what is the integration of this? Now we can easily observe that ki e power, now we are getting in this form, right? So minus sin x, or we can say cos x derivative. Cos x derivative is what? Minus sin x, right? Cos x derivative is minus sin x. So I can say this is our f of x and this is our f dash x, right? So I can say that our integration is finally will get e power t cos t. Now no need to change the limit and all. Okay, just you replace t by again minus x. So we'll get e power minus x into cos of minus x. Cos of minus x will be cos x. And yeah, one negative also will get because our dx will become minus dt. So this will be minus. I'll get minus of 1 second. We'll get e power t minus sin t plus cos t into minus dt. Correct? So this will become, so I have minus already, so I'll get e power t cos t. Okay. So you can see the integration of only this term I am talking about is minus e power t. Again you can replace t by minus x. What will get? E power minus x, and cos of minus x will become cos x. Okay, so we'll get, so this is final integration, I will say, only for this term. So now we can put these in this integration in the main function directly. So what will get? So first limit will be what? Minus e power x cos x, right? That is the integration of c2. So c2 integration is this, minus e power x cos x, right? And minus c1. c1 is what? E power minus x. And since we can see here minus we have, so I will directly write, because e power minus x will become minus of e power minus x, that will become e power. Okay. Now directly you can apply the limit from 0 to pi by 2. Okay. Similarly, let's talk about the second one, c1 integration. c1 integration is what? This one done, right? We can put the limits now. Now let's get the limit of this. Okay, so what we'll get finally? Minus e power minus x, and other will be c2 will be what? Plus e power minus x cos x, and this will be from where to where? Pi by 2 to 2 pi. And at last again we'll get, now it is c2 minus c1, so c2 minus c1 is minus e power minus x cos x plus e power minus x, and this will be defined from where to where? 2 pi to 5 pi by 2. Clear? So let's get the value of this, and after that whatever we are going to get at last, we just have to add everything, right? So we'll get pi by 2, okay, and this will become pi by 2, that will give us 0, right? So what we left with finally? And this will be e power minus 2, correct? So we are going to get e power minus x, it is minus pi by 2, that will give us cos pi by 2, okay, minus what? We can take out e power minus x directly common, so I'll get e power minus x common I have taken, I'll get minus cos x, right, which will give us, and minus also I'll take out common, so I'll get minus 1, and this is from 0 to pi by 2. Okay, so finally it is going to give us, if I put pi by 2, this will become 0, this will become e power minus pi by 2 with negative sign, right? And so this will become 0, so we're left with, and when you put 0, this will become 1, 1 minus 1 will be 0, right? So I'm left with e power minus pi by 2. Okay, so similarly, if I talk about this one, again I have taken out e power minus x common, so I'm left with 1 minus cos x. So from here, again now we put upper limit will give us, again this will become 1, so 1 minus 1 will be 0, so we only have to care about lower limit, so it is going to be what? Upper limit minus lower limit, okay, and lower limit is what? This will become 0, this is minus, so minus of minus, so it will become e power minus pi by 2, okay. Next one will be, so again if I put upper limit, we'll get 5 pi by 2, so we'll get cos 5 pi by 2, you know, and 2 2 pi. For 2 pi again we are going to get 0, right? So let's take out e power minus x common from here also. I'll get cos x minus 1. So this is going to be 2 pi and this is 5 pi by 2, right? So again if you see here, we can take out e power 5 pi by 2 upper limit. So I'll get minus e power minus 5 pi by 2. Okay. So we know that we have to take everything in the modulus because we are talking about the area. So area of this plus area of this plus area of this. Okay. So if we add all, because we have to take the modulus of this because we have to find out the area. So finally I will say that we are getting e power minus pi by 2 plus e power minus pi by 2 plus e power minus 5 pi by 2. Clear? Which is going to give us 2 e power minus pi by 2 plus e power minus 5 pi by 2. Okay. So we have this is our area, that is our, which is equals to what I will say, beta. This is beta. Therefore we can say minus 1 by pi ln 2 e power minus pi by 2 plus e power minus 5 pi by 2 minus 2 e power minus pi by 2. Okay, so we can easily see that it is getting cancelled out. Okay, so what we left with finally, I can get plus 1 by pi into 5 pi by 2, which is ln e, and that will become 1. Final answer will be 5 by 2, which is going to give us 2.5. Okay. Okay, moving on to the next question. Okay, next question is given as question number 17 and 18. So they have given two ellipses, that is x square plus 4y square equals to 1, and they have given other ellipses 4x square plus y square equals to 1. Clear? So they are asking for, let P be the point in the first quadrant where the given ellipses intersect. If theta is the acute angle between the tangents to the given ellipse at the point P, then the value of 4 tan theta. Okay, let's draw the diagram for this. Okay. So you can see one is vertical ellipse, one is horizontal ellipse, okay, and the point of intersection, P be the point in which in the first quadrant where the given ellipse intersect, okay. So if I just try to find out the point of intersection, that is x square plus 4y square equals to 1, and I will say 4x square plus y square equals to 1. So I can directly find out the point of intersection, make the coefficient of x, just multiply the coefficient, this equation by 4. Both the coefficients will be same, right? So when we subtract, this will become 15 and y square, which is equals to 3. So from here I'll get y square equals to 1 by 5. Correct? And since we want the point in the first quadrant, so I can say y is equals to 1 by root 5. Okay. So if y is 1 by root 5, you can substitute any one of the equation here. So this will be 1 by 5. So I'll get 1 minus 1 by 5, that is 4 by 5. So 4 cancel out. So I'll get x value also as 1 by root 5. So we are getting the point of intersection 1 by root 5, 1 by root 5, right? So this point which is in the first quadrant, I'll say 1 by root 5. Okay. And what they are asking for, if theta is the acute angle between the tangents to the given ellipses at P. So this point is P, if we draw two lines, okay, one will be like this. So we need to find out the acute angle, that is, let's say theta. So we all know that to find out the angle between two lines, we just need the slope, right? So if I differentiate the first equation, so this will give us 2x 8y dy by dx, which is equals to 0. So I'm getting dy by dx is equals to minus x by 4y, right? And since we are finding the point of intersection at 1 by root 5 comma root 5, so this will give us minus 1 by 4. I can say this is the slope 1, right? Similarly, if I differentiate the second equation, I'll get dy by dx again at same point P, which is going to be minus 4x by y. So that will give us minus 4, which is our M2, right? So M1 is minus 1 by 4, M2 is minus 4. And we know that now we can directly so if we use the tan theta, which is M1 minus M2 divided by 1 plus M1 M2, will give us minus 1 by 4 minus plus 1 plus 4, this is going to give us 15 by 4, and denominator will be minus 1 by 4, that will become 1, which is going to be 2. So which is giving us 15 by 8. So tan theta we are getting as 15 by 8. So they are asking for 4 tan theta. So we can say therefore 4 tan theta is equals to 4 into 15 by, which is 15 by 2. Which is going to be 7.5, right? Okay, then moving on to the next part of the question. The next part is, if alpha is the area of the common region that lies inside both the given ellipses, then value of chord alpha. Okay. Okay, let's draw the next slide. So again, let's draw the diagram here. So we know that this point is 1 by root 5, which is point P, comma 1 by root 5. Okay, so this time they're asking for common region, right, that lies inside. So they are talking about the area of this. So let's do one thing now. We know that this point is 1 by root 5 comma 1 by root 5. So can we say this point is lying on the line y equals to x? Okay, and we know that this equation of this ellipse is x square plus 4y square equals to 1. So if I just get this area, or maybe this area, so we can easily say that this area and like similarly everything will be symmetric. This area total, all four are symmetric, right? So I can say the area which we are going to get from here into 8 will give us the area of this total region. Okay, so let's get the area of this region. I will say area will be equals to 8 times of, I will say, this curve minus this line. So the curve we can convert into y equals to root of 1 minus x square by 2. So basically area is what? Root of 1 minus x square by 2 minus x. That is from 0 to this point. This point is 1 by root 5. Correct? So we just need to get the area of this, right? So which we are going to get. Area will be what? 8 into. If you observe this key, okay, we know the integration of x. X will become x square by 2. And this 2 we can take out common. Or you can keep it like that only. 1 minus x square, I will write 1 by 2. 0 to 1 by root 5. Minus, I will say this is dx minus integration. Correct? Now, root of 1 minus x square direct integration, we know that is going to be 8 into 1 by 2, and this is going to be x by 2 into root of 1 minus x square plus a square by 2. What is a? A is 1, right? Into sine inverse x by a. And we know that a is 1, right? And this is from 0 to 1 by root 5. Minus what? X square by 2. Okay? 0 to 1 by root 5. Clear? So you can see after this, just we have to substitute the limits, right? And once we'll substitute the limits, we'll get the result. That is 8 times already we have taken. So finally we can say we'll get 8, basically we'll get 0.75 as the final answer after substituting the limits. We can easily substitute 1 by root 5 because if we put 0, we know that this term will be 0, right? So I just have to substitute 1 by root 5 here. And similarly, if we put 0 here also, that will give us 0. So I'll substitute 1 by root 5 and then you can simplify. Here also 0 will give us 0. So I have to just substitute 1 by root 5. So 1 by root 5 will become 1 by 10 here. Okay. And at last you can multiply with 8. So final result is going to be 0.75. And that is the value of cot alpha. Okay. So this is the value of alpha. So cot alpha we are going to get 0.75. Okay. So thank you.